Hello, my name is Quentin Ford, and I will be presenting Multimodal Gaze Interaction for Creative Design. The authors are listed below. Abstract. A new application called Sakura was developed which allows people with physical impairments to produce creative visual design work by using a multimodal gaze approach. The system is tailored to a person for gaze interaction by integrating multiple features. Some of these interactions can be new color selection approach, a control method for manipulating canvas objects, and creative typography. Introduction. Eye gaze interactions have received a significant amount of attention from researchers over the past 3 decades. A strong focus of the work has been centered around the novel eye typing approaches, as well as exploring unique interaction possibilities and the issues associated with gaze input. While a great amount of progress has been made in areas of eye gaze interactions, there has been a lack of research to date on the use of gaze interaction for supporting more visual creative work. Introduction continued. To deal with some of these issues, a new application called Sakura was introduced, which is tailored for the input combination of gaze pointing and a mechanical switch. This prototype incorporates key creative tools that have been adapted in order to make them more accessible for control via the gaze and switch input. So the image you see right now is a Sakura interface. So it's a screenshot of it. As you see on the left side, you have a tools menu. On the bottom, you have additional controls, and in the center, you see the design canvas and the control areas and things such as that. This is the color selection. As you see on the left, you have professional, freelance, and photographer, and letters with the ability to choose numbers. And on the right, you're able to choose various colors by moving the color selection up and down to whatever color is of your preference. Gaps in knowledge. There are some gaps in knowledge in places with little to no work has been conducted. These areas are accurate canvas object selection, object manipulation, alignment guides, color selection, and creative and typography. Technical details. Sakura is a web-based program prototype that uses HTML, CSS, and JavaScript. The application was designed to run in full-screen kiosk mode in Windows 10, which requires an eye tracker that would allow emulation of the mouse's movement. Interface. The main interface was created through the design of already existing applications focused on graphic design. These graphic design applications are things such as Photoshop, InDesign, and Inkscape. It also included things such as digital illustration applications such as Corel Painter, and other things such as Adobe XD, Sketch, and Marvel. Object selection mode. As you can see, for the object selection mode, on the left, it breaks it into like a grid form, so you can choose what object you want. And on the right, it'll show things that has been selected via the cell that is highlighted in gray, which also that shows on the left. And the user can select the tick button to confirm their selection and manipulate the object via standard controls. Transformation handle. So as you see on the left, you have the canvas and you have a blue box that says transformation handle. And with this, you can transform a shape. So as you see on the right, it has a starting shape, and further on the right, it has a transformed shape. So you can transform a shape by resizing it and moving it on the screen as well. Grid-based object selection. Some studies have been conducted to explore different zooming methods that enables users to magnify an element of the interface to support the selection of a small target. Some other approaches can include the use of large controllable cursors to focus on a specific area of interest, as well as the use of gaze gestures to trigger a selection. However, no current research or past research to date has tried to explore the uses of these methods or alternative methods. Object manipulation. The size, location, and orientation of an object are commonly manipulated through the use of small handles that are placed around the boundaries of an object. Using this approach can enable efficient manipulation of objects by mouse control, but presents an issue using gaze interaction to support the graphical work and has yet to explore a solution to the issues. More so, attempting to drag small handles to a specific location on the canvas can present another problematic problem due to the accuracy limitations of eye tracking technology. Study. An evaluation study was conducted with participants who are not disabled in order to investigate whether Sakura enables users to complete common visual design activities. A key requirement for this is that all users are able to use their gaze in order to control the interface and operate a switch for performing multiple selections. 24 participants made up of 10 females and 10 males were selected from a university amongst the students and staff with a mean age of 23.6 years, and 8 participants wore corrective lenses. Procedures. While the participants were given a max of 10 minutes to practice with the system, they had 4 tasks to do. The first task was to add the text "Professional Freelance Photographer" and change the font "Railway." The second task is to add a 1px line above the text "High Quality Professional Photography Service" and make the line blue. Procedures continued. The third task is to select and delete the third image on the right of the design and add a new image. The fourth and final task, a horizontal guide above the 3 images and snap catch of the images. Results. The average completion time for the whole set of tasks took about 22.9 minutes, and each task took under 8 minutes on average to complete, with the first task requiring an average of 4.16 minutes, task 2 required an average of 7.05 minutes, and task 3 required an average of 4.08 minutes, and with task 4 requiring an average of 5.48 minutes. Survey analysis. 3 participants commented that the large size of the cell button helped support their desired selection. 13 participants highlighted having some frustration with some of the most common issues, with 7 participants needing to switch back, gazing on the current button and shifting their gaze back to the canvas. Discussion. Qualitative feedback from the study was very positive and found that participants found manipulating canvas objects via external controls such as buttons, speed options, etc. to be simple, usable, and intuitive interaction approach. Limitations and future works. So some limitations of the works is that participants from the evaluation only completed the defined task once. For future works, new features were added. These new features are the ability to multi-select objects on the canvas, the ability to snap the size of objects to guides, the ability to copy and paste existing objects with gaze interaction, and more options for editing typographical errors. Related work. Some related works can be one of their earliest projects called Eye Painting by Gyps and Oliver, where their application allowed children to draw colored lines on the screen wherever they looked on the screen. Another related work by Honoff and Cavander, they explored a potential solution to an issue through their iDraw application which enables users to signify intent to start drawing through a dwell time selection. A third example of a related work is by Vanderkamp and Sundusted, who looked at the combination of speech input and eye gaze for producing graphical work. Conclusion. In conclusion, the application Sakura enables people with physical impairments to complete visual design work through a multimodal gaze interaction approach. New techniques were added for the selection of design artifacts located on the design canvas, object manipulation, and alignment of graphical objects using guides. Sakura is one of the first applications to integrate each of these features in one multimodal gaze-controlled application. Here are some references. And any questions?